Continuing in section 13.1, we're going to talk about our second type of interest, which is called compound interest. Compound interest is interest paid on principal plus interest. So for example, they might compound a loan monthly. So they'll take the initial principal and they'll figure out interest for the first month. They'll add that to the principal, and then that new total will be used to calculate the interest for the second month, and they'll keep doing that for every month for the year. So here's our formula. For future value A, or the final amount on deposit, including what you started with and all your interest that you've earned, it's principal times 1 plus R over N to the NT. And N is the number of compoundings per year. Present value P, or what you are going to borrow, what you start with, is A divided by that expression. So let's look at computing compound interest. So let's say we're going to have $3,000 deposited in a savings account at 5% for 7 years. What's the future value when compounding occurs semi-annually? This is telling you what N will be. So N is 2 because you're compounding twice in the year. Future value says we want to use this formula. So A equals 3,000 for P times 1 plus 0.05 divided by 2. And then those parentheses are closed, and that's all to the NT. Well, NT is 2 times 7, or 14. So we're going to raise this to 14. Now again, this is calculator work. So you need to grab out your calculator, and you need to find your answer. So I'm going to do 3,000 times, I'm going to do parentheses, 1 plus, then I'm going to do new parentheses for 0.05 divided by 2, so that's all together. I'm going to close my first set of parentheses, and I'm going to raise this to the 14th power. And then I see my answer is 4,238, and I'm going to round at the second decimal because we're talking about money. 4,238 and 92 cents. So that's the full amount in the future. Now this still includes the $3,000 you started with, and the other 1,200 plus is your interest. So it's asking you to try again and just change how many compoundings you do. So if you're compounding monthly, N is 12. So it's the same formula. It's A equals 3,000 times 1 plus 0.05. Now it's divided by 12 because N is changed. And now the NT is 12 times 7, or 84. So now you're raising this to the 84th power. I would try on your own to see if you can get to the answer. The answer is 42.54 and 11 cents. So we have a few more problems that are working with compound interest. So we want to find the final amount in the account and the interest earned. So final amount is finding A. If we start with 5,000 at an interest rate of 8% over 4 years compounded quarterly. So compounded quarterly means N is 4. So A equals 5,000 times 1 plus 0.08 over 4 to the NT. So N is 4 and T is 4, so this is 16. So when you plug this in your calculator, you get $6,863.93. And that represents your final amount. Now they also asked what was the interest. So interest only would be this number minus the 5,000 you contributed. So you take 68, 63.93 minus 5,000, and you'd end up with 1863.93 . So this represents your full final amount, and this represents what part of that is coming from interest. 5 says for a deposit of $14.15 at 7.6% over 3 years, find the interest earned if the interest is compounded daily. Now, the page before only gave us 2 formulas for compound interest. It gave us how to find final amount, and it gave us how to find principal. If they are asking you to find interest only, you have to do it like the one we just did. You have to find A first, and then subtract for your interest. So A is 14.15 times 1 plus 0.076. Don't lose any of that. Just move your decimal 2 spaces and leave the whole decimal value. Divided by, it says compounded daily, so N is 365. That's what we're going to assume how many days there are in the year. So 365 raised to the NT. N is 365, T is 3. If you multiply those together, you get 1,095. When you plug this in your calculator, you get $17.77.32. So that's your future value. To find interest only, you need to subtract. So you need to take 1777.32 minus 1415, and you get 362.32. So here would be your answer on that problem, the interest only. Last compound interest problem is wanting a California couple. They're selling their small dairy farm, but they want to defer receipt of the money until 3 years from now when they can be in a lower tax bracket. So the developing company has a couple of years, actually 3 years, to start saving. So it says find the lump sum that the developer can deposit today. When they talk about depositing, that means they want to find P. At 3% compounded quarterly, so that means N is 4, so that enough will be available to pay the couple $750,000 in 3 years. So this is A. So they want us to find P. So that is the other formula. That's P equals A divided by quantity 1 plus R over N to the NT. So let's plug in here. So we get 750,000 divided by 1 plus R is 3%, so 0.03 over 4, because we're compounding quarterly, to the NT, which would be N is 4, years are 3, so we would say 12. Now if you're going to plug all this into your calculator at once, you need extra parentheses around that whole denominator. So you would say 750,000 divided by parentheses. Then you're going to do extra parentheses to type in the bottom, which is 1 plus, I'm going to do parentheses around my fraction, 0.03 divided by 4. I'm going to close those parentheses. I'm going to close the parentheses around the bottom expression. I'm going to raise it to the 12th power. And then I'm going to close the original parentheses to hold the whole denominator. And now I'm going to hit enter. So we get 678.62. That's how much the developing company must deposit so that in 3 years' time they have $750,000.